So good afternoon all. So today we will solve the problems based on fugacity R and fugacity coefficients. So I think all of you have gone through the week 9 lectures which are available on some portals. So generalize the cubic equation of states. So we already saw the some van der Waals equations, then Redlich-Kwong equation, then Redlich-Kogotsov equations, and Fink-Robinson equation of these are the equation of states. So it is a given the one equation P is equal to RT V minus B minus alpha with function temperatures divided by V plus epsilon B into V plus omega the sigma B. So here given is a alpha function alpha function of temperature is equal to this and B is equal to this. So here is a further different equations given the alpha with functions of temperatures, then sigma value, then epsilon, then spy value and spy value and omega value. Yeah. So here to calculate this ones, here is given for the alpha for Redlich-Kogotsov equations. This is this equation for Redlich. So sorry, Redlich-Kogotsov equation, and this is for the Fink-Robinson equation. This is the beta value to calculate the constant value. Here is a given equation B is equal to omega into P with subscript R reduce indicate the reduce conditions divided by TR means reduce temperature, and Q is equal to spy into alpha with function the reduced temperature and omega and reduced temperature. Okay. So here in this equation put this value. Suppose for the van der Waals, so P is equal to RT V minus B, right? Now here alpha T put 1, right? And V here epsilon is given 0, so this terms 0, and sigma also 0. So V into V into V, so V square. This is the van der Waals equation. Similarly, for we can put the value of the this constant in this equation, then you get the equations. So this is a roots of cubic equation of state may be obtained. So this is a equation. Right. Now fugacity using the cubic equation of states. So here ln phi with subscript I equal to the zi minus 1 minus ln zi minus beta I and qi ii for the species. I indicated the species. So f can calculated once is known fi is equal to iip, right? So here is three roots z1, z2 and z3, right? So here largest is the vapor and less is the liquid, and intermediate is the no significance is like largest v1, v2 and v3. This is the no significance, right? Now to calculate the fugacity coefficient of pure species. So this is a generalized correlation. Phi is equal to phi 0 with superscript 0 into phi with superscript 1 into omega. Right. Right. Yes. So this is the acidic factors. So now phi 0 and phi 1 are obtained from the Kessler tables at a given reduced temperature and reduced pressures. Right. All up clear? Am I audible to all or not?
Sir.
So we will solve some problems. So you may use the following information to solve these assignments. So for cyclohexane, benzene and diethyl ethers given reduced temperature, reduced pressures, reduced volume, and compressibility vector at the reduced condition and acidic factors. So question number 1. So we have to use this information to solve all the problems. Question 1. Consider the cyclohexane at 32.6 bar and 360 Kelvin using Lee Kessler tables. Its fugacity in bar. So you round it up to one digit after the decimals. So here pressure and temperature is given. So we have to calculate the fugacity using the Lee Kessler tables. Right. So we have to use this correlation. Right. Phi is equal to 0 into I1 raised to the power omega, right? So to calculate this value from the Kessler tables, we have to calculate first PR and PR, right? So T by TC, T by PC. Here T 360 divided by TC given for cyclohexane 553, right? So TR is 0.65, PR 32.6, PC 40.7, 0.8, right? And omega given W is equal to 0.210, right? Now TR 0.65 and 0. PR 0.8. At this condition, we have to calculate. We have to find out the value of phi naught, phi 0, and phi 1. Here is the phi 0. So 0.65 TR and PR 0.8, right? 0.0738, right? And phi 1 6.8. is equal to 0.0738 into 0.0543 raised to the power 0.2108. No, 0.04, right? Now to calculate the fugacity, F is equal to phi into pressure, 0.04 into P, 2 times 6, 1.01. It all of that clear?
Sir.
Moving to the question number 2. Consider the benzene at 15 bar and 320 Kelvin. Using a Payne-Robinson equation of state its fugacity in the vapor phase. So you have to calculate the fugacity using the Payne-Robinson equations. Right. Here is the equation given to calculate the fugacity coefficients. So after getting fugacity coefficient, then we can calculate easily fugacity equal to phi into P, right? So this is the cubic equations. And for Payne-Robinson equations, so this is the given. Now, so first have calculated TR and PR, right? TR and PR, T by TC and P by TC, right? There is a T 320 and TC 562 to 0.569 and PC 0.3062. And omega value given here 0.21. Now put the value in these equations. So you will get 3.6489. Now put this value in this equation to get the beta, and phi value this equation. So beta to 0.2902, and similarly put all the value here, you get Q 37.688. Right. Now you have all the value and put in this equation, right? Equation 1. You will get Z cube minus 0.9709 Z square plus 1.034 P5 Z minus 0.4142, right? Is equal to 0. So put this or solve these equations by calci or other techniques. So you get Z equal to 0.5179. If you solve using calci, you will get this value Z is equal to 5179. Now this is the first root. Now to calculate the other roots, we know the for a 3-degree polynomial equations, the summation of roots equal to P, Q, and these are the roots equal to minus B by A. And product of roots P, Q, and R is equal to minus B by A. So we'll get Q plus R, here already negative sign, 0.9709 minus, this is a P, 0.5179 equal to minus 0.5179. 0.453 Q into R, here negative get cancel, 0.4142 divided by 0.5179. 0.5179, 0.7997, right? Now here R is equal to 0.453 minus Q, right? Now put down this R is equal to this value in this equation, this one, Q 0.45 minus Q is equal to 0.7997, right? So here Q square minus 0.453 Q plus 0.7997. This is the quadratic equation. To solve the quadratic equation, first we check d value, means b square minus 4ac, b 0.45 square into 0.79, so minus, means this is d less than 0. So there is a complex solution. We will get a complex solution. So in this equation, asked for the vapors. So generally higher is the vapors. So we consider Z is equal to 0.179. Right. Now we have to calculate I. So Z1 B beta B1 got now QI. Now we have to calculate I. So here epsilon is not equal to the sigma, then I is equal to 1 minus sigma minus epsilon into this term. So we have to use put the all the value. We'll get 0.01912, right? So now ln phi I is equal to z I minus 1 ln z I beta I minus q I, and all the value we calculate. Put the value. So ln phi to minus 0.45899. So 4899. So phi is equal to 0.6162. So we got the phi value. Now to calculate the fugacity, f is equal to phi into p. So here are 6162. The pressure is 15 bar. So 9.19. All have got clear?
Sir.
Move to the question number 3. Consider a mixture containing 60% benzene and 40% diethyl ether at 40 bar and 380 Kelvin. Assuming the ideal gas behavior, the fugacity of benzene in bar rounded up 1 digit after the decimal. So here mentioned that the ideal gas behaviors. So we have to calculate the fugacity of the benzenes. So we know the equation to solve at the ideal gas conditions. So if if one indicator the benzene is equal to yi into p, right? So here yi 0.6 into pressure 40 bar. 40 into 6. 24. Right. It is simple. Huh? A question for consider a mixture containing 60% benzene and 40% diethyl ether at a 41 and 380 Kelvin. Assume that the PVT behavior of this system can be described by the virial equation of state using the only second virial coefficient. Use the generalized correlation for the second virial coefficient and pseudo-critical constant to obtain the cross second virial coefficient. The fugacity of benzene in bar in this mixture. So So you have to calculate the fugacity of the benzenes. We have to use here second generalized correlation for second virial coefficient and pseudocritical constants. Right. The critical constant for the two pure species calculated by using these combined rules. Right. Right. So pseudo-critical constant get from these relations. Right. First, we calculate this pseudo-critical constants. Omega 1 2 is equal to 0.245 and TC 1 2 5 1 1 2 5 2 2, right. ZC 1 2 0.1450 and PC 1 2 equal to 269.21 centimeter cube per mole, right. And PC1 22.93 bar, right. Here R is equal to 83.14 centimeter cube into bar divided by mole per Kelvin, mole into Kelvin, right. Right. So we calculate this as pseudo-critical constants using these equations. Now the three reduced condition can be calculated. So T R 11, T R 22, T R 12. Right. Similarly, T R 11, T R 22, T R 12. Right. So T by TC means T by TC 11, then T divided by TC 22. 0.6759, 0.8142, and here TR1 2 equal to TY TC 1 2, 0.74418, and for PR11 equal to P divided by PPC11. Similarly for other 0.8166, 1.098, right, and 1.74. Now So B naught and B1 here relation given. Now calculate using this value. B not 1 1, B not 2 2, B not 1 2. Similarly, B1 1, B 3, B1 1 1, B 2 2, and 2 sorry 1 2. It minus 0.541 minus 0.4353 minus 0.4858 here minus 0.1154 minus 0.0725 and minus 0.0928. Here T R 11. Suppose for we have to calculate B naught 11. So here T R 11. Put this value here, you will get B naught. Similarly for B 1. Now calculate the Bij. Wait. So using this equation. Suppose B11. So here R is 83.14 bar, sorry, centimeter cube into bar per mole into Kelvin. And TCIg there is a TC for 1 benzene and TC2 for the diethyl ether. Right. Now B11 and B no 0 Ij calculated and omega Ij given. So for omega 11 means benzene and omega 22 for diethyl ether. And Bij calculate from this so B11 is equal to minus 539.68 centimeter cube per mole. B22 is equal to minus 944 into 57 centimeter cube per mole, right? Minus 464.84 and B12 into minus 944.57 centimeter cube per mole. Now put this value in these equations. So you will get delta 1 2 minus 884.62 centimeter cube per mole. Right. Now we have to calculate the for species 1 means benzene. So use this equation. Put all the value here in these equations. So ln phi 1 minus 0.86 pi. Phi is equal to 0.4216, right? Now for fugacity yi p into phi. Here benzene 0.6 into pressure 40 into pi 0.4216. So F1 is equal to 10.12 bar. Right. So this is 10.12 bar. Halapuga clear. So question number 5. Consider a mixture containing 60% benzene and 40% diethyl ether at 40 bar and 380 Kelvin. Assume that the PVT BR of the system can be described by Ping-Ramachan equation of state. In addition, the following equation may be used to obtain the mixture parameter. So I have to calculate the fugacity benzene in these mixtures. Right. So we have to use this equation. First calculate the BI, then AI, then class parameters. So BI. So here as per the benzene's fugacity, so take the value of the benzene's, reduce, critical temperature, critical pressures, critical value. BI to 742.44 centimeter and B2 for diethyl ether. It 29.32 centimeter per mole. B1 742.44 centimeter cube per mole, right? And for class parameters, A now we have to calculate the A1 and A22. A1 and A2. So this is given, so it's the alpha. Now to calculate the alpha value, we have to use this relations. So we'll get the alpha value. Put the R value and TC for benzene and diethyl ether. alpha 1 is equal to 38.33 into 10 to the power 6 bar centimeter to the power 6 mole. Yeah, similarly E2 21.74 into 10 to the power 6 bar meter. Now calculate the cross parameters. So A1 2 A11 into A2 28.86 into 10 to the power 6 bar centimeter square mole square, right? Now I have to call here is a binary mixture, so now we have to call a mix. So put the value here in this equation to you will get a mix 31.13 into 10 to the power 6 unit same. Similarly B mix 7.192 centimeter cube per mole, right? After that calculate the beta and Q value. Beta is 0.9839 and Q 1.26, right? Now put this value in these equations, right? You'll get equation Z cube minus 0.0161 Z square minus 3.63 Z plus 3.1391 equal to 0. So first root is 1.3927. Another is Z cube equal to 0.7537. So this is a vapor in the vapor phase. When highest is a vapors, low is the liquid. Intermediate is not significant. We have to use this ones. Then the question asks for the fugacity for the vapor phase. Now we have to calculate the I value. So here epsilon is not equal to the sigma, so you have to use this one. So put all the value in this equation 0.4480, right? Here to calculate the fugacity coefficient, use this equation. Now you have to calculate Qi with bar using this equation. Next, right. Now first we calculate the A1. So here we have to calculate for the benzene, so use this ones. Here is a mix. A1 37.95 10 to the power 6 bar centimeter 10 to the power 6 mole square. After that, calculate the Q1 with bar using this equations. 3.6981, right? Now put all the value in these equations. You will get ln pi bar minus 0.3571. So pi into 0.6990. Right. Now to calculate the fugacity of benzenes, yi to precious I. So here 0.6 into precious 40 and 0.6990. 16.79. 16.79. I hope all of you clear.
Sir.
Thank you all. I covered all the question based on the fugacity and fugacity coefficient using generalized correlations. Correlation generalize equation from the equation of state. If you have any doubt, please ask.
Thank you, sir.
Thank you. So we will meet on next Saturday. Thank you.